I'll just welcome everybody to what is the penultimate session of PSCC 2020. And very well done for making it this far. It's been, yeah, for some of the organisers, it's been a long week, but I think they've done a great job. I'm not going to say too much about all of this because we've got a closing session coming afterwards, and it will be a bit of reflection. But what I will say, though, is, of course, you know, this hasn't been the format that we were expecting. We were hoping to all have the excuse to be in Porto and, you know, spend some time with each other and, yeah, I've spent some time chatting over coffee and over lunch and in the evening over some other things. But yeah, a lot of people have worked very hard to make this happen. Completely unexpected. It's new for all of us. And although, okay, maybe it hasn't been perfect, but I think it's worked out pretty well. And I want to embarrass my co-chair for this session, actually. In particular, I mean, there's lots of people who've worked very hard, but I want to point out Dr. Dan Molzahn, who I think his efforts on the program have really, really been tremendous. And if we were all in person in the room right now, I would ask for a round of applause. So I don't know how we can do this virtually, but yeah, Dan and of course others, you know, the kind of local organisers in Porto, I think have done a tremendous amount of work. So thank you.
No, and thanks, Keith. I know I've been really fortunate to have a great team of people like yourself to rely on. So I really appreciate all the efforts from everyone.
Okay, so before we get too far into all this spirit of congratulating each other and just saying how great we are, we're going to come on to the panelists in this session who really are the great people who we're going to be learning from, and we're going to hopefully get some good discussion. So please feel free, everybody, to use the Q&A, put a question towards our panelists, and to use the chat as well to kind of engage in more kind of exchange and discussion. Dan and I will be trying to keep an eye on that and pointing questions towards our panel. So yeah, I just want to introduce our panelists, or let them introduce themselves in this session where, you know, our main aim is to kind of explore this question: how can we take research work on software or methods for power system analysis or market facilitation or what have you, the kinds of things we've been talking about this week, into real world use. And I know certainly in my university, and I'm sure many of us are the same, you know, university bosses are always talking about impact. And, you know, there's a kind of a bureaucratic process that the government runs to assess impact and all of that sort of thing. So it matters in terms of income. So yeah, I think it's, for all sorts of reasons, it's a really important topic. So no further ado, I'm going to ask Tom. So please briefly introduce yourself.
Hey, I'm Tom Overbye. I got my PhD at University of Wisconsin-Madison in the US, and we were asked to give our title of our thesis, which I did track down and find, and it was Application of an Energy-Based Security Method to Voltage Instability in Electric Power Systems. Currently, I work at Texas A&M University, and I also work part of the time at Power World Corporation doing software development, particularly during the summer. We were asked to give one short sentence about what we think is the best thing about being a power systems engineer. And I think it is such an exciting time to be in our industry. Things are rapidly changing, which means there's a lot of engineering opportunities, and it's a super exciting time if you're a student to be going into the electric grid area. So thank you.
Excellent, thanks Tom. Now I'll come on to Susana.
Good evening, everybody. My name is Susana de Graaff. I don't see myself, but okay. I did my PhD in Porto University. So if we would have been in Porto today, I would have been home. I did it while I was working in the Portuguese TSO REN and on RISC-TSO, which is a cross-border TSO in Europe, because has the responsibility of the Netherlands transmission system and part of the German transmission system. And the best thing about my job and being a power system engineering is, first, I love it. I really love my job. And this moment, Keith?
So, Susana, thank you. Unfortunately, we had a few communication problems there, so we weren't quite catching the couple of the key bits there, especially when you started saying what the thing is you love most about your job. Can you try again?
Yes, I can try again. Can you hear me now?
Yeah.
Yes.
So I was saying that at this moment, I'm leading at TenneT all the development in system operations, which means that by doing my job, I can make a difference in a way how we will operate the power system in the future. And I really, really love it.
Great. Excellent. Thank you very much. Okay, and now we're going to come to Andreas.
Hi. So I hope the communication will hold up. So my name is Andreas Ulbig. I did my PhD at ETH Zurich in Switzerland. And the topic was, at the time, operational flexibility in electric power systems. So what do I like most about my job in a young startup? I think, well, I like that I created it myself, more or less. Well, not alone, but as a team. So on many days, not on all days, but on many days, I'm actually paid for things I'd like to do anyway. So coming up with nice analytical stuff for grid operators. So that is nice. Let's see how long this continues. But for the time being, it has been a lot of fun, at least most of the time.
Excellent. Thank you. I'm going to come to Britta. I'm going to stop sharing my screen so that Britta can share hers. And then, so Britta's going to introduce ourselves. And then I've asked all of the panelists to give some opening remarks on our kind of main topic. And so Britta's going to introduce herself and then just move straight into that.
Yes, sure. So thank you very much for having me at this penultimate session of this great conference. So my name is Britta Buchholz, and I would like to introduce myself in a way that I work on energy transition all my professional life, and this is really my passion. I started more or less with a PhD, and the title of that, and I also founded, was Smart Web Index and Data Exchange Options, and with a focus on pre-feasibility of PV diesel hybrid systems for remote area power supply. So that was much on simulation, on trying to extract data from the internet and use it in order to find out where to install renewable energy systems in remote areas. And the PhD was in Kassel with, at that time, Jürgen Schmidt and Didier Meyer from École des Mines in Paris, in Sophia Antipolis. Well, then my current job now in the year 2020, and actually since the 1st of July, since a couple of days, is I work with this newly created joint venture, Hitachi ABB Power Grids, which is a large supplier of energy technology globally. And there I have the beautiful role of being responsible for active distribution grids. So in the global market innovation team, that means I work on what does the energy transition need with the focus on the distribution systems. I'm based out of Mannheim in Germany. And as you can see, it's again, or still, the topic of integrating renewables into the system. At the same time, in SIGRE, I have a role of convening a working group that is exactly on the topic of hybrid systems for off-grid power supply. Some things take a while, so this topic made it from research to practice, and also to is rising every day. So what is the best thing? I really work for a purpose, and I really like our new slogan on this new joint venture, Hitachi ABB Power Supply, on powering good for sustainable energy, because actually I started with renewables after there was the explosion of Chernobyl in 1986, when I thought there must be a different energy supply option, and it can't be that nuclear is the only option. So, and now I can really apply all my knowledge that I learned at SIGRE, at the European projects, and with my colleagues and everyone, some people here in the room, I can apply all of that and collaborate with Global Network and to support this energy transition and take it further. So that's, as everybody said, it's an extremely exciting time for power system engineers. That's fantastic. That would be my introduction, Keith. So with that,
yeah, please carry on. Yeah.
Let's see if that works. Next slide. Ah, okay. So you were asking, Keith, how can we translate power systems research into practice, and what would be like our experience or our advice to this panel? And I think the ever most important thing is that that we are enthusiastic. And I learned with enthusiasm we can reach everything. So if we are really convinced of our topics, then we will find a way how to implement it. The lessons I learned were, and what I would like to talk about here in this opening is, as you've seen, I work in the energy transition since over 20 years, and developments take time. So we cannot expect that especially the most innovative ideas make it to practice in the next year or after 3 years. Sometimes they make it after 20 years. And I learned that for example, in my early days working with pioneers of renewable energy in the European R&D projects and in conferences on integration of renewable energy helped a lot in setting the path and creating sort of awareness in the community that it's not only important to talk about generation, but also on the power system behind the generation, and that this is of utmost importance. Always working together with pioneers around Europe, and then afterwards working in the global SIGRE study committee on distribution systems and distributed generation, we could extend that exchange between experts, and we could extend it to a global level. So that was also extremely valuable because early ideas could be discussed with other experts, with other people who are really passionate, who are enthusiastic, who are very constructive, at the same time reflect ideas and also tell why they couldn't work, but in a very constructive way. And this is where we can acquaint a lot of knowledge from experts and learn a lot through this exchange with others in such associations. And then in the innovation teams, first in MVV Energy, which is a distribution system operator where I worked for 10 years, then with ABB, now Hitachi ABB Power Grids, it always strengthened my position having that exchange with external experts around the globe. So then it's the very crazy ideas, you at least know they are crazy, so you don't need to give them up, but at least you know which level of innovation it is. And then I was very much aware that most of the people in the world do not necessarily embrace innovation at all times. So I guess people here on the call are all people who love innovation and love to change things. Nonetheless, in the real world, there are many people who are a bit scared of innovation and who would love to keep things as they are. And having that discussion with experts is always good to find the right words to discuss with the practitioners who are a bit scared of innovation. So that is really helpful. So what I learned, those ideas make it into practice that have been reflected very well before. And best out of the box thinking with diverse teams helps to, right from the start, find the right path to follow. And those ideas that have been reflected in diverse teams for gender, culture, also background, not only engineers, but with psychologists, with commercial people, that those make it best into the practice. Now I work for this large vendor, and of course we want to ensure that R&D money we spend does make it into practice. So that's the purpose of the company. And so we have introduced the GATE model, and where in these business plans that we prepare for GATE models, we consider not only the functional technical specification of any innovation and research, but we also, as soon as we really want to have it in practice in a couple of next years, we consider business cases. So we ask where would the money come from if we had such a solution, and how much would it cost to develop such a product further. So that's not basic research, it's already applied research. And then we also ask the teams to think about marketing mix, which means what is the product exactly, where's the prices, and where's the channel to market and such things. And also we need to consider if the organization is ready for something like that, or what kind of organization would be needed to implement such a new idea. And that means, of course, can it be in a large company? Can it be in the given structure, or do we need an agile new startup organization? Can it be within the company or outside? And probably Andreas will say a couple of words of that on the startup side. So sometimes we better leave it to startups, honestly. Gate model, the charm is that we have a lot of ideas and then we filter them after a while. So gate per gate, we filter the ideas. So from thousands of ideas, only a couple of those make it finally into implementation. And there it's important to filter well in a company in a way that, that really the best ideas make it towards implementation. So Keith was asking me for the single most lesson learned, and honestly, you know, when I started, I loved technology also, and I loved in my PhD, I loved the simulation and doing everything with mathematics. And I found out it's so important to engage with the people very, very early, in a way that those ideas make it to practice that have been reflected, as I said before, from the commercial side, from the psychological side of who invented what, from all kind of sides that practitioners know better than the researcher. And so people don't like to be confronted with ready concepts. People like to be engaged early. And when we engage them early, they are very supportive normally. And then this can make it to reality. What you see on the right is my really my success where things made it from research 20 years ago towards practice. The upper picture you see is in Australia, where a battery energy storage system can supply a peninsula with wind only and a battery for a couple of while. So it can support the upstream network, but it can also island. And that's a microgrid application that is really cool. So one of the coolest projects I know, at least. The lower one is a microgrid that works on solar only for 9 months of the year. It's in Robben Island, in South Africa. And so seeing these two pictures, I always feel so happy, because it shows that after a while, research does make it into really cool practice. And now with this energy transition, we really need more of that. So we need more of enthusiastic PhDs and researchers to come up with the next innovations. Thank you.
Yeah, great. Thanks very much. Okay, so who was I going to come to next? I can't remember now. I was going to come to Andreas, I think. Yeah.
Yeah, so I'm trying to share my screen. Yeah, that actually seems to work.
Okay. Yes.
Can you see my slides?
So we can see your slides and we can still hear you. So that's
okay.
Really
yeah,
good.
That's perfect. The best of the two worlds. Yeah. So actually, what Britta just said is a good. Also, there I have a good connection point to what I'm doing and what my company is doing. So after my PhD, I decided with two friends from ETH to co-start a smart grid startup called Adaptricity, where we're actually really trying to well, put ideas that we developed in research projects into practice. Namely, smart grid topics like using battery storage as a buffer for renewables, and also the concept of using time series simulations for getting a more realistic view of how the grid infrastructure behaves, so close you are to physical limits. And the initial idea was really to enable and increase the amount of renewables that could be put into the grid. So from roughly 7 years ago, actually. So we started to collaborate and brainstorm already before we founded the company. So 7 years ago in 2013, we did first startup challenges and competitions. This was back in Switzerland, back at the time. That was about when it started. And yeah, founding a startup, especially in the energy field back then, was still very, very exotic in a way. the easy way would have been, or the conventional way would have been, to go to one of the grid operators, distribution grid operators, transmission grid operators, to work for vendors like ABB. But we said, okay, well, let's try it. And if it doesn't work out, we can still go to the more conventional jobs. So we were lucky in the end, and Adaptricity developed from a 3-person team into something much bigger, with now customers all around the German-speaking countries, but also in other parts of Europe, in Italy with Enel, with E.ON in Eastern Europe, and in Asia with China Light and Power. But also the company has evolved, of course, a bit. So you'll see that here on the next slide. So how do you transition from an R&D startup to a commercial, from an R&D project to a commercial startup? So 2013, it was really just these 3 guys here. I'm in the middle. I'm actually the last one who joined. So Stefan and Francesco already started 1 or 2 years earlier, and I was still, a bit too slow in finishing up my PhD, but by early 2014, I had it. And then we are developing this software tool that you see here. So focused on time series and data-driven simulation and grid analytics into something for grid operators. And now, 7 years later, we have a team of roughly 25 people, mostly university and ETH graduates who work at Adaptricity as their first real work experience. So it still feels a bit like managing a research group, but of course the stakeholders that you do that for are slightly different. Also, you can see a bit how the software has evolved from something a bit, very techy on the left-hand side to something on the right-hand side that is much more colorful, much more, nicer to look at and to use. That has, of course, a lot to do with the stakeholders that we have now. So instead of striving for the academically most thorough and maybe complicated and new solution, you are aiming for easy and fast solutions. And that then leads me to the learnings. So lessons learned from, in quotations, the real world. So being in a startup is still not the real world, or maybe, well, it's one aspect of the real world, and there are many others, of course. So what did I learn in general? I think, well, in some ways, industry life isn't so different from academia. As an engineer, as a young engineer particularly, you are still striving to solve technical problems. Now it's not for the fame of having a good research paper or for accomplishing the goals of an R&D project at the university, but now you're benefiting different sort of stakeholders, so customers, in our case, grid operators and engineers who do work for grid operators. So that is in a way still the same thing. It's also the same benefit. If you provide a good solution, people are happy, so that gives you gratification in that way. Then in other aspects, of course, industry is very different from academia. So Britta was already alluding to that. So you're striving for, in a way, for practical results now instead of, in a way, academically elegant results that can only be available at some later point. So that, of course, counts much less. Having results now or faster is better. So, and especially in a small startup, that was the case in our first years, you didn't have much funding. So we're always kind of struggling to be able to pay our employees and our own salaries, of course. Most of the time we managed, but not always. So you have different time scales, and especially for a startup, the time frame that you work in is very short. Your cash burn rate is maybe on the range of a few months. So whatever you do has to be productive and helpful quickly. If not, you won't make it. That is maybe a bit extreme, and I would say, if you are naive and young enough, you just do that and you don't think about it too much, as we did. Industry in general, including the energy sector, is in many ways moving much faster. So day-to-day operation is driven by short-term deadlines and project timelines. So that is much faster than, say, multinational research projects that take 5 years, a PhD that takes 5 years or more. On the other hand, of course, it's also maybe slow. Adaptation of new ideas works, I think, often quicker in academia than in practice. For many good reasons, of course. You can't just change horses and technologies from one year to another so quickly, but you also have to work often with, not against, but with very different and conservative mindsets. So you have to convince people that what you do is actually better. And especially in an industry that is very very risk averse, like the energy sector and the grid sector has to be. Getting new ideas applied in practice takes a lot of convincing. And that then leads me to my most important learning. So you have to listen to the stakeholders. In our case, as startups, you have to listen to your customers and really take a lot of time to really understand what the problem or the problems are that your customers or your stakeholders in a more general sense think are the problem and what needs solving. And that is maybe a bit different from academia, where, so I'm simplifying here a bit, we are looking for a problem that fits to your solution. So in the industrial world, of course, that is often the other way around. And so, and for a startup in particular, if you don't find the problem to your solution that you have very quickly, then you have to reiterate even faster in order to get things running and to stay alive. And this is in many ways what we needed to do. So our initial quest has transformed several times into now commercialized products that still work for the same industry, but address very different needs, of course. Thank you. So I'm looking forward to the discussion then later on.
Very much, Andreas. Great.
Mm-hmm.
Okay, so now I'm going to try and share my screen on behalf of Susana. I've got to find the right box to click. Do that, hopefully. And oh, let's page up a bit. Right, so this is Susana's slides. Hopefully everyone can see that. And yeah, so how do we turn power system? Yes, we can hear you, yeah. By the way, I'm just checking, can anyone hear any background noise from me? Because I'm conscious that I'm sitting kind of through the doorway from a kitchen, and there's some dinner being cooked in there, and I can hear some music being played. So I hope I'm not disturbing everybody else.
All good.
I think you're okay, Keith, or at least I don't notice it.
That's okay.
Okay, sorry. Anyway, Susana, over to you.
So let's try to answer Keith's questions with a bit of the why do we want innovation, why we want research, how do we do it, and what are we doing. And but coming back to my PhD thesis that I finished 10 years ago, only now NSOE TSOs are actually discussing the topic 10 years later that my PhD thesis was addressing. And it's very curious to see how my PhD work now finally is being read by a lot of people. We do this, we do innovation, we support innovation because as a TSO and as a very conservative world that transmission system operations are, we are also still convinced that the solutions of today are most likely not the solutions of tomorrow, and that we have to seek for new solutions in order to cope to this very fast evolving system that was already referred by Britta and Andreas. We really need to cooperate with R&D institutions. We really need to seek for innovation. We really need to have several stakeholders engaged with us. And one crucial step in this innovation process is that we actually serve the needs. We actually listen to each other and understand each other to come up with a solution that is workable in the end. And cooperation between universities, research institutes, really supporting and guiding PhD students, seeking for a research that actually can be used and is integrated in the needs of system operations. And I'm here speaking on behalf of a TSO. It's very important. So I am running a development department and I have a lot of students around me. So I welcome master theses. I really go into the topics and I co-supervise together with the university to make sure that I understand fully the work that the PhD and the Masters of Science students are delivering and actually fits our needs, and we can actually use it in the end. We can actually apply it in practice. Can you go to my next slide, Keith, please? So we have a lot of things at TenneT. So we develop internally our own methods. We try to develop the scripts, the mathematics, to find the new challenges, to do the prototypes, to prove the concept. And then after these methodologies in TenneT are really ready and we are convinced that they are the ones that fit our purpose, we actually transfer the knowledge along the company, and everyone in the company can use the developed tools to actually perform analysis. And one of the examples that I have to give is the clean energy package. The clean energy package, which is the European regulation package that is now being implemented, has some different rules for TSOs. For instance, for capacity calculation, there's a minimum level of capacity that TSOs have to provide for market allocation. And that has a consequence. That may have a consequence in the congestions that we have close to real time in the network. So we developed methodologies internally at TenneT, and in this case in my team, to actually analyze the impact of this, this regulation new package. And we cannot do that without the students and the PhDs and the mathematicians and the power system engineers that are actually wanting to make a difference and work together with us. So the team has a lot of rotation. There's a lot of students only doing their research projects and going away, but there's also people that end up staying and end up being part of the team full time. So this is the internal work that is being done at TenneT. But apart from this, there's also a lot of European projects and research Dutch projects that we are participating. Some of these projects, which is a consortium with industry, several universities and TSOs, have actually results that are being implemented in practice. I have 3 examples in my slides. The Migrate project, which actually studies the level of penetration or the consequences of high penetration of power electronic devices in the network, has many slides of things that are being implemented by TSOs. I selected 3 cases. For instance, the grid farming concepts that are being developed for power electronics converters is one of them. TenneT is adopting the specifications for its own network components. RTE is implementing a demo of a grid farming inverter in Osmosa project, which is a follow-up project. Landsnet is also using automatic control based on wide area monitoring in their network live. So indeed, these research projects that have universities and researchers on board are actually being implemented in practice. We have promotion. We have a vision in TenneT to have a North Sea power hub, where we have lots of wind offshore with interconnections between the countries that are close to the North Sea together. And promotion is actually developing concepts, not only technical concepts for HVDC networks, but also regulation concepts. Goes beyond only the technique of the hardware, goes into operations, goes into regulations, goes into protection concepts. And Umbrella Project. The Umbrella Project was the first European project that I was actually active in. One of the work packages of Umbrella Project is an optimization of remedial actions for continental Europe. And this is being prototyped to be used in Europe, for continental Europe, in the moment of network security assessment, which is the moment that there is a coordinated action among all the TSOs with the regional service coordinator, which is or Carrizo or TSCnet. Carrizo is located in Brussels, TSCnet is located in Munich, and they are entities that support TSOs on the coordination for capacity calculation and network security analysis. And we are all together implementing an optimizer that will give a result to solve congestions in the transmission grid for the whole Europe. So there's many examples, but I think the difference here is to really enjoy and really believe, because Einstein said a person with big dreams is more powerful than someone with all the facts. And if you have a dream and you really want to make a difference, just believe on it and try to implement something that one day when you look back, you see it running everywhere in the world. Thank you.
Remember to unmute myself. Somebody had to do it, so it was me. So thank you very much. Right, so great. Now I'm just going to move on to Tom. So I need to push the right buttons here as well. So we can do that. Oh, and cancel and do that. Select that one and share screen. And it's that one, I think. If I do that, then we can see Tom's opening slide, I think.
Yes, you can go to the next one.
Yeah. There we go.
You must be using a different computer than me, but
text has come out a bit small, hasn't it? Oh well.
Yeah, that's
Sorry
okay.
about that.
Everybody's looking at it on their own computers, so if I were projecting this, it'd be very embarrassing. But since y'all are looking at it, you could probably read it. On my slides, it's fine. But I'm going to give a little different perspective. As I said earlier, I work on the academic side as a professor, but I also work in a company that is on the industry side that deals with a lot of customers. And I get kind of a unique perspective in doing that. Keith, I think it's okay because I can just say that. I think we've got a problem, and the problem is on the academic research side. Our industry is rapidly changing and has lots of need for research. And as I said in my opening, it's a really exciting time to be in the electric power industry because there's a lot of cool stuff going on and we need research. And I see that in talking to customers on the industry side, there's a lot of needs out there. But a lot of times the academic research is not aligned with those needs. And to some extent, I think on the academic side, we've lost touch with the essence of engineering, which I did look up the definition of it, and I'm sure it varies from language to language and place to place. But in English, in Merriam-Webster's dictionary, it says engineering is the application of science and mathematics by which the properties of matter and the sources of energy in nature are made useful to people. And I think that's what all of us, if most of us, if not all of us, that's why we got into engineering, because it was so cool, because we wanted to do useful things, be it working as a professor or working at a startup or working at a large company. You want to do useful things. We as university researchers want to do useful things. The problem, though, is that there's this valley, and this is an image that I picked up online. I think it came out of a U.S. National Academy's report, but it's well known in terms of this valley. Oftentimes it's called the Valley of Death. It's that on the left side, you've got basic research that takes place primarily at universities and to some extent government labs. And then on the right side, you've got industry, and industry has the needs, and hopefully on the left side, we meet the needs. The problem is a lot of that basic research goes into this valley of death. And there's lots of reasons for this. In power systems, which is our focus here, particularly software, the valley should not be as deep because software you can easily translate from research into practice. And I will say that I sit on both sides of this valley and move stuff across the valley quite readily, but I see some problems for the most part in our generally doing that in the industry. Keith, you can go to the next slide. If you're a practitioner, you may not understand this, but maybe you do. A lot of academic research is driven by money and publications. If you work out in industry, you might not know what an H-index is or how many times your papers have been cited and things like that. But if you're a university researcher, particularly a young one, you know all about this. And you know, this journal has this impact factor and things like that. You want your work to get noticed. And people write papers, I think, hoping that somebody in industry will pay attention to them. The problem we have is that our publications are not really well focused on the needs of practitioners. Too often, the easiest papers to publish, and I'm talking about publishing in our top journals, are ones that reduce system complexity to allow for rigorous mathematical modeling. And Andreas used the term academically elegant. And I have on here simple and elegant. These get well reviewed because most of the reviewers are academics and they sit on the left side of the valley and they think, is it mathematically rigorous? How many equations does it have in it? I need to put in these equations so that people think I'm doing rigor in that. The issue, though, is that there's often little industry interest in these things. Very few people from industry pay attention to our papers. That's just how it is. And the more equations you put in the paper, the less you're going to have people paying attention to it. And I work with a lot of developers, and I think we do really cool stuff. And some of them are very jaded on the publication process because they think the papers are just going to be reviewed by people that really don't know much about large-scale systems, and they're not going to accept them. They're going to say, it lacks mathematical rigor. And I think this is really sad because I see the needs in industry, and I know that if I send my students to the academic journals, there will be very few papers in the academic journals that actually talk about making stuff useful. And that's sad, and I think we need to change it. We need to have a focus in our top journals on publishing more engineering papers that show something is being made useful. I will say, since Anjan Bose's name popped on the screen here, when I was in industry, I worked as an engineer, a bachelor's degree engineer for a couple of years. I used to always read it wasn't transactions on power systems, then it was transactions on power apparatus and systems or something like that. I loved Anjan Bose's papers because I could understand what he was talking about, and they were very relatable. They had profound concepts in them, but he was able to relate, he was able to write, and I think he still is able to write in a way that is very transparent, and that's good. And industry people like that. I would love that if we could get industry people interested in transactions on power systems, for example, and they felt like, wow, this is addressing my needs. You can go to the next page. The next slide. So in putting this last slide in here, I did want to give a few practical tips because I know that if you're somebody in the audience there, maybe you're a grad student, you're saying, well, what can I do to change our publishing culture? And the answer is you probably can't do a lot. It needs to be done collectively by the entire research community. And we have to say collectively as a community to the editors and the reviewers, we want more stuff that tells about how the grid works, what the challenges are in industry. If you're somebody starting out and you want to make an impact, what I tell my students all the time is learn how to write and learn how to present. You want students that can write well. And if you can write well, your ideas are going to get across a lot better. In many venues, I would say minimize your use of equations. I'm not against mathematical papers, and there's certainly a venue for highly mathematical papers, and there's some real good benefits. And I'm in awe in some algorithms, but the problem is that we've gone overboard, and 90% or something like that of the papers are heavily mathematical. I know why, because people can get those papers accepted. Another practical tip is if you're working in the power systems area, work on large scale systems. That's hard to get a lot of times because the data is not usually public, but we've done a lot of work in the creation of synthetic grids. Some of this has gone on in Europe. A lot of it has also gone on in the United States. I've got a little thing on how to get our grids there. Think about how your research could actually be made of use to industry. Do internships in industry, that's a good thing. Read in related fields, because usually we want power system engineers that know power systems and something else. And then, as has been talked about here, particularly with the startups, you need to take some risks. So I'll finish with that. Thanks.
Okay, thank you very much. So yeah, some very interesting and different perspectives. I think a lot of common ground between our panelists, but yeah, Tom especially there is laying down a challenge. I'm going to come back to some. I've got some comments on the chat. I want to have a look at that, see if you've managed to stir them up, Tom. Yes, there are already some interesting comments. While I have a look at these comments, I'm just going to kind of, something that Susana said, I'm going to come back to first of all. Susana, you said something like, the solutions of tomorrow will not be the solutions of today. But I would say, well, maybe quite a lot of industry is still using the solutions of yesterday.
That's true, but with the new Green Deal in Europe, we are committed to decarbonize until 2050, and that will enforce an integration of energy systems. And also our plans in the North Sea to put 140 gigawatts of offshore wind will pose some balancing and flexibility challenges, and probably some system dynamics that are faster than the ones that we have today. And that is for sure a field that needs attention and needs research and development, that we can actually operate or automate more the system operations in a way that we can cope with the challenges of tomorrow with less synchronous machines and with much more fast and higher magnitude system dynamics. That's why the statement. And we have much more interaction also in distribution networks. So there's also a lot of research field there, that we have a lot of flexibility, a lot of services that are coming bottom up from distribution into transmission systems, which will help us also to operate the power system.
So that's one of the big kind of maybe changes in the last 20 years is about the active distribution networks and how important they are. So Andreas, I mean, one of the things that struck me about your comments was you know, just who your customers are. I think maybe as a distribution, or someone who's doing distribution system analysis, maybe in the German-speaking world, you've got many more distribution, you know, DSOs who could be potential customers. Yeah. Certainly where I am in Britain, we've got 8 of them, and you know, some of them are easier to work with than others. But at least you've got some customers there potentially. But I don't think any of them are here. I mean, there's some comments on the Q&A I see starting to come through now. Patrick Pansiatisi is saying, how many industry people are here? Patrick is good. He always comes. That's great. But not many others. Britta's here.
Hi,
Susana's
Patrick.
here. But I mean, you're in a bit of a minority, aren't you, Andreas? How, you know, so A, you know, have you got enough customers? And B, you know, is it still worth your while coming to a place like this? And why don't the DSOs turn up?
Yeah, I think they're turning up more and more. I mean, the DSOs have a bit of their own events as well, right? They have the Siret workshops.
It's part of the challenge, isn't it? Is maybe we've got sort of these silos if they have their events.
Yeah, I mean, I think we definitely have a silo of, you know, there's the transmission grid people here at PSCC, and then, but I also, I mean, many PhD students after their PhD are now going to DSOs because actually working on the energy transition in the distribution grid is much more interesting now than it was 10 years ago. So this is a bit more where the fun is these days. So I think you will see more people, Well, actually, what I think will happen, a lot of the young people that you have now at PSCC will in 5 years down the road work for distribution grid operators. And then I think there will be more people coming to PSCC and similar events to present their practical work because they already know the venues. I think this is what you will see more and more. And well, is there enough DSOs for a company to be commercially successful? Well, I think there is, because the DSOs, they manage 90% of the grid infrastructure, right? It's, you know, the low voltage, medium, and even the high voltage part.
In some countries, it's like one DSO that manages the whole country's distribution network, isn't it? So,
sure, but that can be then a very lucrative client to have.
Okay, well, you can get in. Okay, so
yeah, exactly. That's the point. If you can get in, I think we were lucky that we actually started in markets that are super fragmented, like Switzerland and Germany. So it's actually quite easy to get the relevant people on a table and discuss with them. Because these organizations are maybe 1,000 people or less. So you can actually make an appointment with the CEO or with the head of grid operation or asset management or something like that. And what we did, we actually started working out with a lot of smaller DSOs, got references, and now our clients are getting bigger and bigger because they see the existing references, they know the companies, although they are much smaller than themselves, but they can relate and take this as a legitimate reference. And now we are working with much larger companies like E.ON and TenneT, where of course, if we would go there and just knock on the door, probably not that much would happen. But having these references, especially from city utilities, that are actually, as it turns out, the innovative bunch. I mean, where Britta worked at MVV in Germany, this is a well-known city utility that is very innovative. Maybe also thanks to Britta while she was there, but still is. We had a discussion with them today. And there are others that push the boundaries and the limits of what can be done and what is, say, innovative practice, but legitimate and say practical enough to be then also be adopted by others that look up to these more innovative utilities. So I think there's definitely that. And given the fact that the energy transition doesn't really happen in the high voltage grid, at least not directly, right? I mean, you're connecting PV plants to the distribution grid. Even most of the larger wind parks you're connecting to the distribution grid. So I think there will be much more work to do for the younger generation and the DSOs, and then also more research output out of that, because the new problems tend to be also there, which was not really the case in the past. Right?
So don't we have a bit of a tension there, though, that I've just had this feeling, for example, that it tends to be the smaller companies that are maybe more innovative and more kind of agile. I see this, where I am in Britain, that, the suppliers that are kind of actually being innovative with flexible demand and new tariffs are the small ones. And what you seem to be saying there seems to be sort of saying, the smaller DSOs are the ones who are more interested in trying out a new idea. So we've got, Susana and Britta here are both working for quite big companies. If you can get in with a big company, you can make a big difference. But like you said, it's a different difficulty getting in. So, Britta, is it an unfair criticism of big companies that they're a bit slow to innovate?
Well, that's why you have positions like mine, where the agile part in big companies, and you have the R&D. No, but I think what has been said is really right. I mean, really, with the distribution system operators, we cannot forget that 10, 20 years ago, they didn't have much challenges to innovate. So the innovation culture wasn't that well established. At MBV, it was established very early. And as I said before, I brought that European network into the company as well. So with the support of European research partners and strong universities, small companies can make a difference. And sometimes it's good to start with the smaller companies and then the larger ones adopt it a bit later. Having seen that it does work, or what I also see in a global company is that like in Germany, people adopt things that they see in Australia. And in Australia, they happen first, and they are pioneers really in active distribution grids, and now the German DSOs learn from them. So it's kind of a exchange. Now I see, and Susana and I discussed it a lot in CGRE, where practitioners and academia meet a lot, and where TSOs and DSOs discuss we have seen that you cannot separate that any longer. So when I was leading the study committee on distribution systems and this first generation, that was one study committee. And by now, distribution elements have been placed into all over SIGRE, which I find great. So it means it's not a silo any longer. And more working groups cover exactly that exchange between TSO and DSO. And I think that's the journey. We should really work together and listen to each other, listen between TSO, DSO, implement the right topics, and have a trustful collaboration that leads towards energy transition.
Yeah,
and
good,
Susana,
thank
I
you.
think you wanted to comment.
Susana,
right away,
well, cool.
Yes. I couldn't agree more with you, Britta. We are integrating and coordinating and cooperating intensively more and more. And indeed, DSOs and TSOs will work intensively together to create the new solutions that we actually need in the future. And you are absolutely right. In SIGRE, we cannot separate it anymore. I am leading study committee C2, System Operations and Control, and we see the intensive interaction, and the borders don't exist anymore. So we are interlinked, and all the topics can have a participation of both TSO and DSO in order to find solutions. So indeed, it's becoming a truly integrated system, vertical and horizontally, because also TSOs have to work a lot and very intensively with the other TSOs in the meshed system. So it's becoming one system. And now probably we will start also the integration of new energy sources like hydrogen and power to gas and power to heat. So it's becoming a very big, complex, very challenging energy system. But I couldn't
This
agree
raises
more
a lot
with
of
you.
opportunities, doesn't it? And a lot of need for research, it seems to me, to understand how all these things are going to go, how, you know, from the level, we were talking about this in the tutorial on Monday, I think, actually, you know, of, you know, there's investment decisions to be made, and then there are operational decisions, and, you know, the more interactions, the more complex it is, and the more we come back, I think, to the kinds of methods that we're talking about at this kind of conference, and some of the software to try to analyze it and give confidence to kind of operating optimally. So, you know, Tom said earlier that he said it's easy to transition software into industry. So Trevor Gaunt has made a comment on the Q&A saying, you know, although Tom said it's easy, Andreas has kind of done it. Britta and Susana are both saying, oh, well, it's kind of hard. You know, how can, you know, Tom, how can you get a researcher engaged? Okay, Britta wants to answer this, right? Okay, kind of rising to the challenge. Or I'll come to Britta and then we'll come to Tom.
Sure. Yeah, sure. I mean, I mentioned earlier, I love associations like SIGRE or conferences like this one because you have a chance to meet. And I think it's extremely important that researchers present their ideas and get a chance to present that to companies, to industry, to utilities in a friendly environment. So not like people killing them with the first idea, but people kind of thinking about it and discussing it. And such associations like SIGRE or the European conferences also, they're very well positioned to do exactly that, where you have great experts and very young researchers with great ideas. And if that meets, then it's a fantastic situation to take something further. And then the correct organization must be found. Like my organization is really agile in a way that I'm absolutely free to decide on a relevant topic and set up a team to do something. I mean, that sounds strange, but that's a very agile part in a huge company. And huge companies do have such teams, and so that's why it's me to be here and to talk also to researchers and everything.
Yeah. So yeah, Tom. I mean, it's another question actually. You might be able to pick up as well. I see on the Q&A. In your experience, do TSOs or DSOs have an R&D budget to sort of come and meet halfway? I think there's another comment on the chat about the importance of meeting halfway. Tom, is this? You know, you're pushing at an open door, or you have got to kind of batter it down?
So let me clear up the idea. When I said about transferring software, I said it's easier to transfer software compared to making hardware. And I've dealt with with friends who have had startups in the hardware space, and they immediately get into making prototypes and manufacturing facilities and things like that. And I would say, hey, for us to manufacture, this was back when we were making CDs and stuff, we just cut a few CDs and mail them out. Now it's all online. So our manufacturing is easy. It's not easy. And Andreas would know, as I know, when you're dealing with meeting the needs of industry, you have to meet the needs of industry. And you've got to make the solution fit the problem, not have a solution that you go looking for problems, because they bring you problems and you better solve those problems. And when I put up the chart that showed the valley, I did want to make sure people understand there are people in industry that work effectively on both sides of that valley. Usually we know them by just one name. And I saw Patrick had a question here. I didn't read the full question because but I saw his name. I think you mentioned the name. Patrick's one of those guys that goes by one names. I was joking with him. I think actually the last time we were in Porto, which was 3 years ago at IREP, that he seems to be everywhere. Although on this one, he didn't have to travel, but we see Patrick a lot over here in North America.
I'm sure it's come as a great shock to Patrick to have to stay at home for a while.
Yeah, that's something we're all dealing with. But there are people in industry that work on both sides. Kind of the takeaway from what I was saying is I feel like too much on the academic side, on the left side, we actually self-police ourselves by how people review journal papers to keep people from venturing across or to go further out. And I think that's sad, because if I say to my grad students, find some papers on this and that, a lot of times they don't find stuff on what's really going on out in industry, large scale system solutions. And I think we need more of that. And as I said, as academics, we are driven by the H-index. I write a lot of tenure and promotion letters. So there's people that I review a lot of applications from these people, and practically I always say good things about them. But you look at their papers and you wonder, I mean, some are having great impact and others are like, they're writing papers and they're getting a lot of citations, but it's not much that would be used practically. And I'm
with you on this. I mean, I think, to be honest, but I'm supposed to be independent as the chairperson here, so I don't know. But we still got a healthy audience, so please, if you want to kind of respond to Tom there about how the academic journals are useless. That's a slight exaggeration.
I didn't say useless. They're not useless. They've got a lot of good papers in them, but there's a lot of papers that are on equally useful, because you could write a very strong theoretical paper and it could be a great contribution to a journal. And we've all relished those papers, and some people can do that very effectively. Like I called out Anjan Bose. I mean, Anjan Bose has done that throughout his career very effectively. They're strong on the technical, but also quite readable and appealing to industry. So it's not saying we don't need to have those papers. It's saying we need to have more papers. You never know
which one out of those. I mean, somebody's just put on Mads has put on the Q&A. You know, how many thousands of publications there are every year. What does that say about academia and funding agencies? Maybe we'll come back to that question. But you never know. One of those 3,000 might be the one that makes a huge difference. Britta, you wanted to come in as well.
Yes, I mean, I have that. I have also a bit of a role in translating between science and practitioners. And what I recommend to everybody who writes a paper is to write an abstract that a normal engineer can understand. So I think, and that's something that I use then. For example, we say, okay, you must be able, every scientist must be able to communicate at least 3 sentences about what this paper is about. And these 3 sentences should be understood by at least a normal engineer. So that's what I challenge everyone writing papers that I review. And that's something that industry can use very well. That's something that I can share with management, with anyone. So also if scientists want to enter like our company, with good ideas, it's of tremendous value if this abstract can be understood by a manager who is also an engineer. So that helps a lot. Just my advice.
So Susana was waving there. So I maybe I'm going to say representing a normal engineer, but you're not a normal engineer, Susana.
No, but I have I have a development team with people that struggle into say words instead of mathematics, and one of my concerns when I have a young PhD or a young Master of Science with me is to actually put some of my effort explaining them how they can communicate their equations with the outside world, because this is of utmost importance. If you have the best mathematics or the best engineering solution in the world, but no one can understand it, it will not pass through. So I really hope that all the researchers that are listening to us have a very good supervisor that invests time from his own to actually tell and train and develop the students also in that area.
Well, but it's also the reviewers and the editors that have to say, how is this paper making things better? And this paper doesn't have a lot of equations in it. I don't have to automatically reject it by saying it's not rigorous enough. It could be making a very, 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 very strong engineering contribution. I looked up one of Anjan's papers on, I think, a dispatcher training simulator. I think he had one equation in there. He said x dot equals f of x. And it's like, well, good.
Yeah. Okay. So Britta, a quick comment from you. Then I want to come to Andreas, who has had the luxury of sitting there quietly for a bit. So we're going to break
Yes.
that in a moment.
I-
By the way, just before I come to you, sorry, Britta, if you're making a comment on the Q&A, and there's some great comments coming in, it'd be great if you didn't feel the need to be anonymous, because we're not going to tell anyone else. Okay, you know who it is. So please give your name. We want to give you credit. So anyway, sorry, Britta, go on.
Yes, no, I mean, you were asking about the single most important lesson learned. The second single important lesson learned was that I realized that the most capable experts are able to express themselves in very, very simple ways. And if somebody thinks he needs to talk in complicated ways in order to seem to be an expert, that's not right. So in my experience, the real good experts do manage to express themselves in simple words. And so I encourage all the PhD students to strive for that brilliance in making complex things sound easy. So that's a real strength.
Yeah. And so Andreas, I mean, I'm really impressed with how Adaptricity has grown. And you've hired, 24 people.
Well,
so
no,
how do you
35.
kind of approach that when you're looking at who you're going to hire? Are you hiring the top mathematicians, or are you hiring in general, or are you hiring the people who can translate the mathematics into, everyday engineering language?
Yeah, more on the practical people. So actually, we are still in a way quite well connected to ETH, as our university. I was for the last 5 years still giving a part of a lecture at ETH. And always had the opportunity to say, hey, look, this is, by the way, if I'm not lecturing, this is my hobby startup that I'm doing. And we have a cool office space. And so this way we attracted actually a lot of master students and internship and people for internships. And this is here in many European universities, this is a mandatory thing to do an industrial internship. And so we got quite a few people out of that. And when the opportunity came, so we had a position to fill, some bright people that were currently there. So we grabbed them and hired them as software engineers or engineers for industry projects. So this is how we recruited. That probably won't be continuing for, say, the next 20 years, because then other startups come up that are younger, fresher, I don't know. But so far we have been quite lucky that we are so close to a big university where a lot of young and talented people come out. And of course, and that was said already before, I mean, working in the energy sector as a whole, and working in grids is now much more interesting than 10 years ago for for the young graduates, right? We actually do work quite a bit on math. So we use a few equations here and there. We just don't show them so much to our customers, unless of course they ask for, say, specific technical realizations of how we do certain things. And I fully agree with Britta. I think there's much talent in translating complex things into easy sentences. And especially in the grid world, I mean, you talk to a wide range of people, right? And I mean, you have people that for the last 20 years, they have been like physically putting cables underground. And they're not mathematicians, but they actually have 20 years of experience. So they might know one or two things much better than I would do. Like now we are working on asset management, and it's actually super interesting to listen to those people and what sort of accidents and material failures they have seen over the last.
They need to improve their health and safety.
Yeah, well, but they can tell about these like funny incidences that happened with cables in certain conditions, and it's super interesting. And there's actually quite some value in that if you can, like really analyze what happened. And often the people who didn't got much, say, university training or haven't seen a university at all. I mean, they are still clever in what they are doing. They have done it for a long time. And it's really impressive to listen to them, and of course then try to translate that into more general outcomes.
Yeah,
But that's definitely kind of a thing that you need to learn once you get out of the university realm, that other people without much formal training have a thing or two to say as well. Yeah.
So my own experience of kind of my career, I feel I've learned a lot from the kind of practical people. I haven't spent any time out in the field, which maybe is a bit of an omission. But how can we kind of shortcut that process? So for researchers who are, in the lab or, in a university, all of us, I think, on the panel have been saying more or less, try and be practical, try and understand the application. How can we enable people to do that? I mean, you've just said you've taken students on internships, which is fantastic. My experience in Britain, very few of the companies that were in the power systems sector are doing that.
Okay.
So,
yeah, I guess in the German-speaking countries, I mean, that is that has been there. That system has been there for a long time. So that is often a requirement. So it's just there, and all companies that I know, they hire interns and have industrial master's theses where they pay the students actually, and they benefit from that because it's also a recruiting channel, not just for startups, also for, and maybe that would then be an incentive also in Britain if you have recruiting challenges.
That's what I try to say to them, but I'm not sure they're really listening maybe I'm not communicating it in the right way. Maybe I'm not.
Yeah. Well, I can connect you the next time you are over here. I mean, I can connect you to people from the local DSO industry. I mean, this is how they recruit their people, essentially. Yeah, have them as interns and then just get them once they are done. So that I'm sure that also works in the UK. Yeah, maybe we were discussing about papers and incentives there, and I've seen that in the chat as well. Maybe there should be a bonus if you can point out to practical relevance in a paper, right? I mean, it can still be mathematically sound and elegant and all of that. I mean, that is always a plus, and a good theory makes a good practical application as well. But if you can actually showcase, hey, look, this and this thing I did has this and this practical relevance, then I think, well, first of all, you show that there is a relevance and you get some sort of a bonus point. And of course, the paper is then more interesting for practitioners who would read, okay, for this and this reason, this should be beneficial. And then they will take the time to actually digest the whole thing, I think.
When I'm a reviewer, normally my first question is, how do you see this being applied? So when I give them a chance, I don't just say reject, do not resubmit. I normally, if it's reasonable in other ways, I say, revise, and I ask them that. So anyway, but Dan wanted to come in and say something about competitions and stuff.
Oh, yeah. So I think this question that Roger asked was really interesting, where he says, maybe the industry could publish the research questions they care about and allow people to, participate that way. And I've been thinking about this a lot recently because, I mean, as Tom knows well, a lot of these synthetic grids that they were creating are going into this ARPA-E, Department of Energy, GO competition. which laid out standard problem, same hardware, everyone, and then they funded, I forget, 25 or so teams to go try to solve this very particular problem. I know the folks at RT would talk about Patrick. Patrick has, his group has put together some more competition style. There was one paper here on grid operations and maintenance planning as a competition they're kicking off. And I know they have some machine learning competitions in Europe for operating power grids. Is that a path forward? Does industry care about this? Is this a reasonable way to approach it, or is this kind of a waste of time and energy?
So,
well, Dan, given that I'm involved in these competitions, I'm not going to say they're a waste of time and energy. I think actually a lot of great things has come out of the ARPA-E competitions, both the current ones and ones moving forward. And I saw a comment here about synthetic grids and data sets as like real is best, but it's really hard to get real grids or real data sets. So we're trying to do realistic, but not real, so as good as we can.
Yeah. And
they're getting better. They're not perfect, and we're never going to be real, but just like Pinocchio, never real.
Yeah, Britta, you wanted to say something in answer to Dan?
Yes. I mean, you were discussing the challenges. I mean, from industry side, we do work with a lot of universities, maybe not with too many, but with selected strong and also young universities on certain research questions. So when we have research questions, we would pick one university or another or research partner to work on it. Nonetheless, I fully agree, and students reflect to us that this format of challenges is gaining importance, and I will like to have feedback from the audience as well. So I think we are very willing to invest a couple of days or weeks into a certain challenge that wouldn't go over a year. It would be kind of 4 weeks challenge or something like that, with a couple of experts being available to also rephrase things, to answer questions and so on. And I think that level of engagement is much more attractive than just throwing out a question. So I think if we do something like that, we would love to get to know the PhDs and the researchers, and would like to get engaged and then come up with something that's really useful together, and getting to know the persons, each other, and the persons get to know the company. So I think that's a format that will come up more often, and we're absolutely willing to jump on such a journey.
An interesting comment has come up, I think, from Sheriff saying, yeah, thanks for all the comments, but how can academic researchers find out about what is happening in the inverted commas real world? And there's a similar comment, I think, from Marina on the chat as well. She wants industry to come up with tailor-made and well-thought decisions. So yeah, then if I'm trying to see if this is what you're saying, maybe it's a responsibility on industry to define the problems and explain the problems, and then engage the researchers and say, hey, look, here's our problem, which is a bit like what the competition is trying to do, isn't it? But then it's quite a sort of specific thing, which is great. And Patrick's put a link to an example of a competition on the chat now. But there's a lot of this kind of other stuff, which is sort of a bit more intangible, maybe sort of, I don't know what's the right term, kind of implicit knowledge that's not in a textbook. How can we get out of it? Tom is waving now. Go on, yeah. Come to Tom, and then we'll come to Susana.
Well, that's what wouldn't it be great if we could go to the journals, the top journals, and there's stuff on this that's dealing with practical considerations, that, here's a case study, there's a case study. It's not going to be everything, but it's going to be some of the papers in there, and they're going to be helpful to people. That would be great. It's not saying we don't have the highly mathematical papers, because there are some that are really useful, but there should be others. And I will say there are editors that you submit a paper to, and they're great, and they pick wonderful reviewers, and it works fine. The challenge is it's very much pot luck. I mean, you can get an editor or reviewers that are like, this doesn't have 100 equations in it, I'm automatically rejecting it. It's too non-rigorous. And that's wrong.
Yeah, I mean, this point about rigor, there's a comment from Xiao Duan on the Q&A. if we want to draw a reliable conclusion, then a theoretical analysis plus simulation plus prototype plus experiments are all indispensable. So
no,
okay,
they're
right.
not. They're not. That's the thing, is you study these large systems and people think I can get a theoretical result on it and they'll have a 2-bus system or 14-bus system, and isn't that great? It's like, no, we're doing studies on a 100,000 bus system. We've got like 300 different model types in there. And it's like, there's major challenges. And if somebody says, you need to give me a theoretical foundation on this, it's like, well, maybe I just need to give some results of the challenges we're dealing with. People are saying, where are the challenges? Why can't we have that? We've got it and we want to publish it. It's just people will say, no, where's your rigor? You've got to have this theoretical foundation. It's like, no, I can put that, I can provide references to this and to that. We all know the theoretical foundation. That's not the contribution of every paper.
So I suppose, I mean, the quality of evidence is still important, isn't it? I mean, I think we're in an age where lots of, certainly in politics, you know, there's a lot of politics by assertion rather than by pointing towards evidence. And to be fair to the comment, I certainly feel that my kind of, my mathematical chops have kind of fallen away over the years. You know, it's like, you know, you don't speak a language for a while, it gets very rusty. So I feel like so the fact that, you know, mathematics is a language in itself, and I think that's, for me, that's a very fair comment, and I'm just kind of losing the ability to speak it. But at the same time, I you know, it's a really important point about what the real challenges are and how do we communicate them. I think so. Susana, it was a few minutes ago now, you were wanting to say something.
Yeah, I want to go back to how can the researcher or the student get connection to the real world, to the real problems, and to the knowledge that is not translated into only equations. And from my point of view, when I have a problem and I search for a researcher or for a student or for a partnership, I invite people to come and work with us almost full time to actually understand exactly what we are speaking about, to actually get immersed into the topic. Because if I have a research question and I just launch it to university and say good luck, most likely I will not have the outcome that I want. And apart from equations and from competence in mathematics, I also want people to understand the problem. Another thing that I would like to address is how you recruit people, because I work with very smart people. They are really, really very good. And if I see someone that is being a student with me or is in a research project that pops up to being very smart, very clever, very capable, I try to put that person inside the company. If not in my team, in a location where there's place and there's a job fitting that person. So I think we industry are also trying to search for the bright minds that we need to help us to prepare the future. We also have a part in that, not only universities.
Yeah, I'm very pleased to hear you say that. Yeah, Britta.
Yes, and fully agree with you, Susana. And adding to that, I think it's up to everyone to expose yourself to accept challenges. So be it in an association or ask your professors that you want to get connected to industry. I think it's up to everybody to say, I want to go there. And then normally people find you. So the universe will find those who are really enthusiastic and really want to do something. And coming back to what I said in the beginning, so the enthusiasts will be found and they make their way to where they need to be and will make a difference.
Yeah,
it's not easy. Nobody says
no,
that's easy. It's never easy.
Something I think maybe you or someone else said earlier about the need for perseverance, you know, and keep trying, you know, maybe. Sorry, go on.
Not just one example. I started in microgrids where there was no industry at all, not at all. And then when I joined ABB, I told everybody, once ABB jumps on microgrids, I want to be part of that. So I told that to everybody, literally. And then suddenly I got a call, Britta, we need a product manager, a global product manager. What about you? And then I put my PhD on the table and said, that's my application. It's 15 years old, but it's still valid. It's just, I mean, just to give a funny example, and that's that's a bit the way.
No, it's very good. I'd like to see. So you never know. The idea comes to fruition So, you know, don't lose hope.
Yeah.
So I think there's a lot of kind of angles we could take now. I'm conscious we're coming into the last 5 minutes of our scheduled time. And I've really enjoyed the discussion. There's a lot more we could talk about. So a couple of things, so maybe we'll try and to sort of bring up before we finish. I think something you said, Britta, about the need for kind of diverse groups. And there was a quote I wrote down for me when you were speaking. People like to be engaged. And what that made me think of was a kind of, it's a bit sad really, but a kind of not invented here kind of culture. I don't know if everybody knows what I mean by that. You know, where if it's not your idea, you don't quite embrace it in the same way. And I don't know if this is what you were kind of meaning, Britta, but because that does exist, you have to kind of offer someone a little bit, give them the chance to criticize it, and maybe they kind of start to believe it's part of their idea, and there's a kind of collective ownership starts to develop. Is that the kind of thing that you think works? Is that what you meant, or you?
Yeah.
Else in mind?
Well, the not invented here is something that's for sure true in some parts. It sounds a bit, well, it's not really negative, but it sounds as if people were kind of egoists or something. But I think once somebody asked me, do you want to be right or do you want to make an impact? And I said, I want to make an impact. And then sometimes it's better not to insist that I was right in the beginning. So sometimes it's better to ensure people understand me. It's good to listen to see where the problem of a decision maker is and rephrase my solution in a way that it solves the problem that my decision maker has. And the decision maker can be anyone. So I think that goes into direction of not invented here, but is a bit more subtle in a way that it needs collaboration and understanding. Yeah. And what I learned is that I'm in my topic all day long, but others are not. So I must give others a chance to understand what I'm talking about, because they live in a completely different world.
Yeah.
And that's, I think, very important.
And that kind of, I think that different world, or the different personalities, I mean, engineers, mathematicians, computer scientists, we're a bunch of quite idiosyncratic people, aren't we? So, there's a bit of generosity that is needed perhaps to kind of bring everybody with us. But I mean, coming back a little bit to what Tom was saying earlier about the kind of academic incentives, I mean, maybe, Tom, they don't quite drive us towards or bring us towards that kind of cooperative, let's have an impact rather than just be right. Academia isn't quite like that normally, is it? What do you think, Tom? How do we stop it being like that, or become a bit more collegiate and generous?
Well, what I've found in the academic world is populated by people who make up the regular world, and some are very collegial and fun to work with, but it's not necessarily everybody. And yeah, I mean, if students say, hey, you professors are kind of quirky, it's like, yeah, I wouldn't disagree. We've all got our quirks. But I mean, I've had very effective relationships with a lot of people over the years, both in industry and in the academic world. And I will say, for any of the students out there who are considering becoming professors, one of the greatest thing about being a professor is being able to work with all of these bright young students, and that is a lot of fun. And I really miss not being able to see my people. I see them often on Zoom, but working with students is a great thing. And that was shared by some of the others here, that you bring these great students in, and it's wonderful. I really like that aspect of the job. But I will say I've had some great colleagues over the years as well. Yeah.
I agree. I think it's a real privilege to be doing the kind of thing that we do. So maybe that's a good kind of little wrap up. I want to go around everybody just as we reach 1/4 the hour. I'm going to pose a little kind of statement, and I want you to sort of give your response to it. It's kind of a discuss. It's a bit like an old style exam paper, isn't it? You may use both sides of the paper. Well, you can't use both sides of the paper. We haven't got enough time. But let me find what my question was going to be now. What's more important from a PhD? What's written in the thesis or the person? I'll come to Andreas first on that one.
Mm-hmm. That's good. I was thinking about this question early on. I actually think the person is more relevant. and you can judge it quicker. I mean, you can put ideas into your PhD thesis, and for 50 years, nobody cares about it. And then all of a sudden, boom, you might get a Nobel Prize at the age of 90 or so. But when you are, I mean, it has happened, right?
So you're nowhere near 90 yet, are you, Andreas? So there's still time,
no, I'm not banking on it. But I think, I mean, you can very well judge, you know, the person that comes out of it, this like very analytical, motivated person that spent a couple of years on a certain topic out of self-motivation. I mean, that person is valuable right away. And I mean, for the person itself, for an employer, for whoever, everyone around this person. So I think the person that comes out of it is relevant. So we as teachers, and I include myself here, I mean, we have to make sure that we teach our students that, I mean, that they can think straight and analytical, and, you know, they can analyze a problem down to the foundations, and then strive to come up with solutions to that. And they should understand the setting as well. So especially in the energy sector, would be good if they have a more broad understanding of energy and economics and politics around it. And that is, to me, short term, of course, the more value. And, you know, for some of the PhD students, 20 years down the road, some people find out, well, they were actually right.
Yes, yeah, cool. Actually, sorry, on that point, I remember when I did my PhD thesis, and I was invited to apply for a position in a very large British company involved in the power sector. And I didn't get offered the job, and I wrote to them and asked for some feedback, and they said, your interest in environmental conditions and emissions is not consistent with our activity as a customer-led company. I'm pleased to say that company has changed its position since then. But anyway, so on that kind of, you know, what's more important than a PhD, the person or the thesis? We'll come to Tom, and then Susana, and then Britta. So Tom.
My answer is quick. It's the person. And if I had to say advice to the PhD students, also greatly value your other students as colleagues, because you might be working with them in one form or another for a long time. And those relationships. So yeah, we want you to do a thesis, and we get that, but foster the relationships, and of course grow as a person too.
Thank you. Yeah. So yeah, Susana.
It's also the person, because I think people are actually the ones that can make a difference in this world. So the person is the most important, and the development of that person is very, very important. And like Andreas said, a PhD is a person that is trained to think analytical, to go down into a problem, to come with a solution on its own. So in the end of the process, that person is prepared to face the problems that are new in the world, independent of the success or of the work that is inside the PhD. So for sure, the person and the development of that person during the process.
Great. And in danger of the panel breaking out in violent agreement with each other here. So we come to Britta, and your view on that.
Yes, so I think for a global industry, for us, it's important. Well, we assume somebody has the knowledge when they have a PhD from a good university. But the person must be willing to work in global teams. So we need team players who are willing to respect other cultures, other people, who's willing to learn English or bad English as our corporate communications language. So that's next to the topic. It's so important to have a team player and to have somebody interested in other people and cultures.
Yeah, great. Thank you very much. So, I mean, we've gone 5 minutes over our time. I'm sorry, but everyone will hopefully hang around for the closing session. There's a comment I've just seen on the Q&A. Definitely the person, because no one ever reads a dissertation. Actually, I put an epilogue in my thesis, and this is a long time ago now. You can tell by the greyness of my hair. And I said something along the lines of, well, is this going to make any difference to anyone? Probably no one will read it. It will just gather dust on a library shelf until the library is demolished to make way for a car park. And then I was trying to argue about what should happen, what might, in an ideal world happen with this sort of ideas I was putting across. And actually, when I then went for a job a couple of years later as a postdoc in Manchester, And there was an elderly senior professor he happened to have been my external examiner. And he'd been external examiner for about 50 PhD students. But he remembered my thesis. He remembered it. He remembered the epilogue. I don't think he remembered anything else about it. And what I thought was curious as well, he didn't seem to realize what kind of my political persuasion was from the epilogue, where I thought it would have been obvious. But anyway, you never know who might read your thesis under what conditions. So look, we're gonna wrap it up here. And thank you very much to all of our panelists. We've talked about networking as being such an important thing, and we've missed that this week, of being able to have all these conversations, you know, over coffee, over lunch, over a beer, whatever it happens to be. It's not quite the same thing with having the Q&A and the chat and the text, but I've really enjoyed this conversation that we've been able to have, and we've had a bit of interaction with people who've stuck around. It's Friday evening here in Europe. I've not had a beer yet this evening. I'm looking forward to it, having a bite to eat. For anyone who's stuck with us from China, it's well past midnight. It's just the afternoon in the US and South America. But anyway, thank you ever so much to all of our panel. Actually, in many ways, this was made easier, wasn't it? That you know, the travel was much less problematic. So yeah, do stick around. Take a bit of a break now. Stretch your legs. Get a cup of tea or whatever happens to be the right time of thing. Good stuff. The right thing to have at this time of day. We'll come back for the closing session in a few minutes. I'm going to put up a little slide to do with the closing session now, if I can find the right one, where we're going to have a few reflections from the chair of the executive board of PSCC. So PSCC is this not-for-profit organization. It's been going for, what, 50 years now, running this conference, which I think is a great conference. So a bit of reflection on how it's gone this year, looking ahead to the next one. And then the president of the conference will declare it closed formally in a few minutes towards the end of that closing session. So thanks very much. I'm going to close down my video. Don't log out. We're going to be in this same virtual room for the closing session. And hopefully we'll see a lot of our attendees for that. And thanks very much, and see you soon.
Thank you.
Thank you.